Hey, this is Pranshi Verma. Today on my channel, we are breaking down the OSI model in plain English, no techie jargon, just straightforward insights into the world of networking. Let's dive in. Let's start with introduction. What is the OSI model? The Open Systems Interconnection (OSI) model describes 7 layers that computer systems use to communicate over a network. It was the first standard model for network communications, adopted by all major computer and telecommunication companies in the early 1980s. The modern Internet is not based on OSI but on the simpler TCP/IP model. However, the OSI 7-layer model is still widely used, as it helps visualize and communicate how networks operate and helps isolate and troubleshoot networking problems. OSI was introduced in 1983 by representatives of the major computer and telecom companies and was adopted by ISO as an international standard in 1984. We'll describe OSI layers top to down, from the application layer that directly serves the end user, down to the physical layer. Let's understand every layer with their functionalities one by one. Let's start with the application layer. The application layer is used by end-user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to users. A few examples of application layer protocols are the Hypertext Transfer Protocol, HTTP, File Transfer Protocol, FTP, Post Office Protocol, POP, Simple Mail Transfer Protocol, SMTP, and Domain Name System, DNS. Next layer is presentation layer. The presentation layer prepares data for the application layer. It defines how devices should encode, encrypt, and compress data so it is received correctly on the other end. The presentation layer takes any data transmitted by the application layer and prepares it for transmission over the session layer. Next one is session layer. The session layer creates communication channels, called sessions, between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when communication ends. The session layer can also set checkpoints during a data transfer. If the session is interrupted, devices can resume data transfer from the last checkpoint. Next layer is transport layer. The transport layer takes data transferred in the session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer. The transport layer carries out flow control, sending data at a rate that matches the connection speed of the receiving device, and error control, checking if data was received incorrectly and if not, requesting it again. Next layer is the network layer. The network layer has two main functions. One is breaking up segments into network packets and reassembling the packets on the receiving end. The other is routing packets by discovering the best path across a physical network. The network layer uses network addresses, typically Internet Protocol addresses, to route packets to a destination node. Next layer is data link layer. The data link layer establishes and terminates a connection between two physically connected nodes on a network. It breaks up packets into frames and sends them from source to destination. This layer is composed of two parts: Logical Link Control, LLC, which identifies network protocols, performs error checking and synchronizes frames, and Media Access Control, MAC, which uses MAC addresses to connect devices and define permissions to transmit and receive data. And now the first layer, physical layer. The physical layer is responsible for the physical cable or wireless connection between network nodes. It defines the connector, the electrical cable or wireless technology connecting the devices, and is responsible for the transmission of the raw data, which is simply a series of zeros and ones while taking care of bitrate control. Alright, you can learn all the layers in a very simple way with the abbreviation IPDNTSP. Let's move further and understand the advantages of the OSI model. The OSI model helps users and operators of computer networks determine the required hardware and software to build their network, understand and communicate the process followed by components communicating across a network, perform troubleshooting by identifying which network layer is causing an issue and focusing efforts on that layer. The OSI model helps network device manufacturers and networking software vendors create devices and software that can communicate with products from any other vendor, allowing open interoperability. Define which parts of the network their products should work with. Communicate to users at which network layers their product operates, for example, only at the application layer or across the stack. Let's move further and discuss a very important model, TCP/IP model and OSI versus TCP/IP model. Let's understand TCP/IP model first. TCP/IP model, or Transmission Control Protocol Internet Protocol Model, is a conceptual framework used for understanding how different networking protocols interact within a network. It is the foundation of the Internet and serves as a guide for the design and functioning of network protocols. The TCP/IP model consists of 4 layers, each responsible for specific aspects of network communication. TCP/IP model, or Transmission Control Protocol Internet Protocol Model, is a conceptual framework used for understanding how different networking protocols interact within a network. It is the foundation of the Internet and serves as a guide for the design and functioning of network protocols. The TCP/IP model consists of 4 layers, each responsible for specific aspects of network communication. In the TCP/IP model, OSI layers 5, 6, 7 are combined into one application layer. OSI layers 1, 2 are combined into one network access layer in TCP/IP. However, TCP/IP does not take responsibility for sequencing and acknowledgement functions, leaving these to the underlying transport layer. Let's discuss some other important differences. TCP/IP is a functional model designed to solve specific communication problems and which is based on specific, standard protocols. OSI is a generic, protocol-independent model intended to describe all forms of network communication. In TCP/IP, most applications use all the layers, while in OSI simple applications do not use all 7 layers. Only layers 1, 2, and 3 are mandatory to enable any data communication. Alright, folks, that wraps up our deep dive into the OSI model. I hope this journey through the layers has made the world of networking a bit clearer for you. If you found this video helpful or if you have any questions, don't hesitate to drop a comment down below. I love hearing from you. Before you go, make sure to give that thumbs up if you enjoyed this content. And if you're not already part of our tech-savvy community, hit that subscribe button and ring the bell. You won't want to miss out on our future explorations into the world of technology. Now, whether you're a networking pro or just getting started, remember that understanding the OSI model is like having a roadmap for navigating the digital universe. Feel free to share this video with your friends or colleagues who might find it helpful. Thanks so much for tuning in today. Stay curious, stay connected, and I'll catch you in the next one. Happy networking!